Start with the easy one, I think. So what's the answer to this one here? So, yeah, without the water balance, we can't do water accounting, right? It's all about this this idea that inflow has to equal outflow plus the change in storage, right? So that's a key. Good to see most of us agree. Okay, so this is what we just talked about. The idea that yes. Okay. Good. Remember when we talked about groundwater yesterday? We said there's no new water that's being made by the ground. That's not how it works. The water has to come from somewhere, right? So there's no new water. It can move place, it can move in space, it can move in time, but it's always the same amount of water, right? Okay, so that's the conservation that pass. Like something happened to it. Hold on. Can you not read that question? Okay. So the change in storage is used to compute net inflow from gross inflow. Is this true or false? This is true, right? And does anybody remember? Can someone give like an example of this? I guess gross inflow is typically like which fluxes would be gross inflow? It's usually precipitation, and maybe depending on how you draw your domain, maybe surface inflow and groundwater inflow, right? That's gross inflow. Okay, so to get net from gross, but let's use the ballet because it's a little bit easier, right? In that case, we drew our watershed boundary, our domain for our water counting, in such a way that there was no groundwater or surface water. So the only inflow was from precipitation, right? So how do we go from that to net inflow? What do we have to do? Exactly, yeah. And if water is coming, I always have to think about this. So this is, if the groundwater, let's say, is increasing in water level, so the change in storage is positive, right? Is net inflow bigger or smaller than gross inflow in that case? So this is the thing I always have to. It's backwards, right? Remember our equation here. So in equals out plus change in storage, right? Okay. Now this right here is gross inflow, right? Can we make net inflow? Net inflow is in minus change in storage equals out. Okay, this right here is net. This is gross. This is net. Okay. So this is why it's confusing when you think about it in a second. So the storage actually increased in my example, right? So that means delta S is positive or negative? It's positive. But see, when we make the net flow, we subtract off delta S. So is net bigger or smaller than gross in this case? It's going to be smaller, right? Okay, so this is the counterintuitive thing. When the storage in the domain increases, net inflow is less than gross, right? Can we think about why this is? I think I lost my water bottle. Has anybody seen my blue water bottle around? I honestly, I think I must have left it at the restaurant here. Hopefully we'll find it. But I use this for example all the time. I need my water bottle. But, well, let me just draw a picture. Okay, if this is my domain, and we can think of it like maybe here's the groundwater. Okay, so we have in, and then we have out, and we have some change in storage, right? Okay, so if the water coming in, if some of it goes to increasing the storage level, then that means, like, let's say 100's coming in, and then let's say 10 goes to storage, changes, like an increase in storage. That means we really only have 90 left over to do something for depletion and outflow, right? Because 10 of that went to storage. So that's why the net inflow is less, because 10 of it went into storage. It's not necessarily that it's bad, that's good, you're storing the water. It's just that it's not available for depletion and outflow now, right? And if this is negative, like if the water level went down, so it's negative 10, now how much water do I have available? Sorry, I shouldn't use the word available. How much water is there for depletion and outflow if this is negative 10 and I have 100? What is the answer here? 110. You see how it's kind of counterintuitive? I always have to think about this. It's backwards from what we expect, right? So, and the reason is because this is acting like another supply of water now. We're taking 10 from here and 100 from here, so we have 110, right? If we're putting water there, we have 100, we put 10 here, now we only have 90 left, right? So that's why we take off. Okay, this one's working. I don't know what's going on. I think it's good.
Yeah.
Yeah?
Okay. Chúng tôi có mà tôi nghĩ là thì change in storage là cái sản phẩm gì net này gross này có machine nào trên đó đó bắt đầu nó có thế cái một trong những gì là một cái gì mà nó sẽ không có bảo vệ không có giá này ông xã đi alo bao đi bảo mà alo bao đi ông xã đi gross này cái cái mà nó cũng anh đi nè tôi lại cái gì vậy đấy hả mà nó bảo nè cái net của mấy chị đều phải nhưng mà bà net net bảo flow đấy net inflow rồi ông cái đó là gì cái gì đấy chúng ta đó nó mà nguyên bao đấy chứ mình thắp bao đấy chứ nó không là bây giờ chúng nó ồ anh mà cái mà sau cái gì cái này cả nhà bây giờ không làm được nó không được xong bây giờ đó cái gì gì vậy là không phải tại vì gì hết đi gì không này lời cái gì thì bao gồm đâu mà chúng ta thích thật vụ đó là một phần là do một đồ gì ông sao à cái đó thì mà chỉ là ông sao như là cái da đấy khi là mà bị mẹ thì đâu của người nói không biết đó thì hay thì ông sẽ thì người nói gì thì thế mà khi để chúng nó số chả phải làm đấy thế làm đấy nhà ở giờ thì mà nhà là chỉ có nhà là chỉ để cho người có thì nguyên đấy ông xã cái nhà đó luôn thì đâu được không gì à bây giờ này mà cái đồ đấy áo này tôi nét tí mà cái đó xí nguyên đấy ông xã của hạt nhà đó nguyên là quá một đứa này nó thì hạt nhà nó không lùi ra mà không lùi ra bây giờ không hiểu cái đấy thì nếu mà sao đều mà để họ tin người ta chỉ về từ lâu đâu cho người ta chuyện này ông xã thì nếu khi cái nào có ပြန်ပြီးတော့ထွက်သွားလို့မရဘူးလားပင်ကအောက်လဲထွက်လို့မရအဲ့ဒါတွေမကဘဲနဲ့ကိုဒီတဲကနေပါယူလို့မရတော့ဘူးရပါဘူးအဲ့ဒါဆိုရင် net ဒီဘာဖြစ်သွားမလဲအဲ့ကြတော့ net ကများသွားတယ်ဒါပေမဲ့ net ကများသွားတာဆိုတော့ဒီတွေကနေပါသွားမှာဖြစ်တဲ့ကြောင့်မို့ဒီ storage ထဲမှာဒီဒါကဒီမှာတော့ plus ဖြစ်တယ်တော့ဘာဖြစ်သွားမလဲ minus ဖြစ်သွားโอเคလားโอเคလားရပြီနော်သိမရဘူးတိတ်လေးလိုတွေသေးတယ်ကျွန်တော်အခုတစ်ခေါက်ပြန်ပြောမယ်သူကအခုကျွန်တော် domain လို့ပဲသတ်မှတ်ကျွန်တော်ပါဒီခွက်တစ်ခွက်ကိုပဲလောကသတ်မှတ်တာနော်အဲ့ခွက်ထဲမှာဒီဟိုဆိုရေကအစထဲမှာရှိပါလေ storage အနေနဲ့စုထားတဲ့အနေနဲ့ရှိပြီးသားအခုကျွန်တော်လည်းမနေ့ကရေရင်းနဲ့လည်းငါကြားတယ်အဲ့တော့အောက်မှာရေလောင်ငံရှိတယ်ပေါ့ဗျာရှိတဲ့ဥစ္စာကိုရေရတယ်ဘယ်ရောက်ဝင်ကျွန်တော်တို့တခြားသောဝင်တော်ကြီးတွေဖြစ်တဲ့မိုးရွာတွေလောကလာရေချောင်းရောက်ဝင်နေစီးဝင်လာဥစ္စာရှိလားအဲ့ဒါအကုန်လုံးဘာလို့ခေါ်လဲကျွန်တော်တို့ inflow လို့ခေါ်တယ်inflow ဒီတိုင်းရိုးတက်မယ်ဆိုရင်အဲ့ဒါဘာလို့လဲခေါ်မှာလဲ gross flow ပဲရှိသေးတယ်အတတင်မဟုတ်သေးဘူးအဝင်အကုန်လုံးပေါ့အားလုံးပေါင်းတယ်ဒါပေမဲ့အဲ့ဒီပေါင်းတဲ့ဥစ္စာကိုဒီဘက်ကနေဝင်နေဒီဘက်ကဘာလို့လာလဲပြန်ထုတ်လို့မရဘူးလားထွက်လို့မရကျွန်တော်ခတ်သုံးတာရှိမဲ့ဟိုသူကသူစီးပြီးတော့ပင်လယ်ထဲစီးသွားတာမရှိနိုင်ဘူးလားဒါပေမဲ့အဲ့လိုစီးတဲ့ဥစ္စာရှိတယ်အဲ့ရှိနိုင်တဲ့ဥစ္စာကိုပြီးတော့အဲ့ဒီ storage ထဲမှာဒီမဖြစ်နိုင်တယ်အပြောင်းအလဲ change ဖို့လို့ကျွန်တော်ပါတယ်ကြားတယ်ဟိုတေချာနဲ့ကျွန်တော် data နဲ့ပြတယ်နော်အဲ့နဲ့ပြတဲ့ဆိုတဲ့ဥစ္စာမှာအဝင်ကထဲကနေပြီးတော့ storage ကယူလာတဲ့ကြောင့် storage ကတိုးလာလောက်လိုက်ပြီဆိုရင်ဒီမှာဆိုရမှာဖြစ်ပါမယ်အပေါင်းဖြစ်ပါတယ်အဲ့လိုအပေါင်းဖြစ်သွားတာနဲ့အများဒီဘက်ကကိုပြန်ဖတ်ဖို့ပါပေါ့တရားဝင်တာပြန်ထွက်မလားမထွက်တော့အဲ့ဒါကြာတော့မလို့အဲ့ပြန်ထွက်တဲ့ဥစ္စာကိုတက်နိုင်ဖို့အတွက်ပြန်ထွက်နိုင်မဲ့အလားအလာတက်နိုင်ဖို့ဒီ in ရဲ့ဥစ္စာအတွက်မှာ net လို့ခေါ်တယ်အသက်တွေဘယ်လောက်ဝင်လဲဆိုတဲ့ဥစ္စာဒီ storage ထဲမှာရှိတဲ့အပြောင်းအလဲကိုထည့်ပြီးတော့တွေ့ရတယ်။တက်မဲ့ဒီဥစ္စာမှာဖြစ်တဲ့ storage ကတိုးလာတာဖြစ်တဲ့အခါကျရင်တော့သူ့ကြီးကတော့တော့ပေါ့ဗျာ။ storage ဒီမှာ storage ကတိုးလာတာဆိုတဲ့ဥစ္စာတွေဒီမှာကြာတာဒီ minus sign နဲ့ပြအောင်။ okay ဒါပေမဲ့အဲ့ဒီ storage ကနေပြီးတော့မတိုးတဲ့အချိန်ကို storage ကများနေပြီးသားဖြစ်နေကြအောင်လို့သူကသူထပ်ပြည့်လို့မရတဲ့ကြောင့်မလို့ဒီအဲ့ဆိုရင်အထွက်ဒီထွက်နိုင်တဲ့အနေအထားဒီဘယ်လောက်မှရှိသွားမလဲဟိုတရားထက်တော့မှကျော်သွားမယ်ပေါ်သွားတဲ့အခါကျရင်တော့ဒီ storage တရားဟာပါနှုတ်ခြင်းလဲနှုတ်သွားလို့ရတယ်โอเคရပြီလားနော်โอเค yeah
I think I have a quick picture I got in my mind. Maybe we share with you. Okay. So I need. Okay. So this right here is change in storage. This is storage. Okay. And we're gonna measure people. Okay. So maybe you guys are over here.
Yeah.
So let's stand over here. And this is our domain right here, right? They're outside of the domain, and I'm inside the domain, right? I'm in storage right now. Okay. So now you guys come in, and then I join you, and I come walking. Now we go. Okay. So what happened with storage? Did it go down or up? It went down, right? But what happened with the amount of people we have? It went from 2 to 3, so it went up. See, the person from storage joined the people coming in, and now there's 3. Right? Okay, so can we go back now? We go. So now we're all out of the domain again, right? So now we walk in. And you guys keep going. Yeah. Okay. So how many people came in?
3.
Yeah. And what happened to storage? Did it increase or decrease? It increased, right? And then what happened to the amount of people left? It's less now, right? So you see how storage goes up, the amount of your resource goes down. If storage goes down, the amount of your resource goes up. See, it's a little bit counterintuitive, but I think this makes you remember this, I think. Yeah, okay. Okay. So we never make this mistake now. We got it. Okay, thank you. All right. anybody know what mitochondria are? Yeah. Pleistocene. I think we have some geologists in the room. Pleistocene. Anybody knows that one? You guys know that? Yes. Okay. So this is the same. This one. Remember, this only has to do with space, and this only has to do with area. So even with space, it's not right. Right? In terms of spatially, we have the area and what else? The vertical component, right? Okay. So always think about the space and the time of our domain, okay? If I ask this tomorrow, 100%. Read it again. Read it again. What is a flux? It's something that crosses the boundary of your domain, right? It doesn't have anything to do with what's happening inside your domain, right? What do we call when the amount of water in the domain changes? What do we call that? Okay, so what is this? It's a change in storage, yeah? So this is not a flux by definition, right? So this is false, okay? All right. It's a tricky question. Okay, great. So all of the above. So this is, if you answer this, this is correct, but actually so is this, so is this. So it's all of the above. So good. I think we got that. This was another thing that people, I think, we were a bit confused about yesterday. So, what's the answer here? Oh. So these are the two conceptual things. I think the one about the flux, and maybe I'm not asking the question right or something, but it's just the key. It's concepts. Yeah. Yeah. So what this committed water, what does this mean? We remember our water balance. The committed water is the water that's going out of your domain. It's a flux that you can't change. It's committed, right? When you're committed to something, you can't change it, right? That's the definition of committed. Means you've made an agreement. So you can never think about using committed water in your domain as a depletion, right? It's like protected water, okay? And you can't use it in the domain. So maybe
committed and committed. No, committed look at it out you about a Kian view, Pia made down level, don't go there. Queran, Pia, level, Queran Chara will be outside. Go to get up, took only, we are told to go in. And committed they are told only. And committed Marava, for Salah, and committed and the Kushi, ချိန်မှမရနော်ဒါမှမဟုတ် committed လေအဲ့ဒါကိုယ်ထဲမှာသုံးပါလားကိုယ်ထဲမှာသုံးဖို့ဖြုံးတယ်ကတော့ဒီပြီးတဲ့လောကသုံးသားဖို့လည်းမဟုတ်ဘူးစီးထွက်သွားတဲ့အထဲကအောက်လို့တွေကမှသုံးဖို့အတွက်သက်သက်မှတ်ချထားပြီးသားဒါတော့ကုန်သွားမယ်လို့ရှိပြီးသားရပြီလားခုဆိုအဲ့ဒါနောက်တစ်ခုတော့ရတော့ပြီSo I nearly gave you the next question away.
Okay,
I think
that's all right. That's all right.
Yeah. Not exactly. It's all right.
Okay, great. So again, these are all true. The best answer is all of the above. Has anybody from the back won? I'm trying to remember yesterday. I think you won yesterday, right? One of you guys, I think. So someone from the back has won, if I remember right. Okay. So this one will break my heart. We don't get this one.
No, we should get like 100%.
Yeah. So what's the right answer on this one? Oh, okay. Well, I'm glad that 90% of us believe that this is true. Maybe it was just
Maybe the other three, like, I don't know. We have only a study, right? The other three are maybe late driver.
Okay.
They didn't get all of it. Yeah. So they don't make it hard.
Okay. 90% is good enough, I guess. Now, it's a fact that you need data to do water counting, but this is kind of an opinion here, so I'll let you guys agree or disagree with it, and I'm glad to see that most people agree. Does the person who disagrees want to we can talk at the tea break. I think it only helps, right? It only helps. For example, if I never did these quizzes with you, and I never knew how you were like getting the information, does that make me a better or a worse instructor? Right? If I don't have the data, I can't know, how it's going, right? So this is the same thing. If you want to have, good, sustainable use of water resources moving forward, you have to observe them. You have to measure them, right? It can be remote sensing, citizen science, smartphones. There's all sorts of ideas, but we need to have the data. Okay. Actually, I'm sorry. I just realized that one of these answers kind of is also true, but this is a quote. Okay, yeah, good. So as I was reading them, I thought, well, maybe this is actually a decent answer too. But good. So who said this? Does anybody remember who? Kelvin. Yeah. What is Kelvin? Now that you're not looking at the screen, the notes. Do you remember who he was or where he was from? Yeah, he was Scottish. He was like a mathematician. He's got that unit named after him, right? The Kelvin scale. Okay. So we have to listen to him. This is getting into what Huspa talked about yesterday. So water use efficiency can be different at different spatial scales. Is this true or false? Wow, Huspa, good job. There's more people that got your answer right than that they think that data is important for Myanmar. So this is excellent. I'm very, very happy to see this, right? So Huspa talked about the distribution, right, efficiency, or maybe just the on-farm or the field or the whole system, or even the basin, right? It changes depending on where you draw your what? Your domain, right? So depending on how you select your domain, this number can be quite different. Okay, very, very good, very encouraging. So, water use efficiency can sometimes be misleading. Is this true or false? What do we think? Okay. Can someone give an example of how this can be misleading? Does anybody remember some examples you talked about yesterday?
Which is like irrigation efficiency, and that's the water which is given to the other channel. We are focusing in that area, but irrigation efficiency is different.
Yeah. Okay. Very good. Very good. Yeah. Exactly. So like, well, I'll do the next question, but that's very good. The next question, I think, gets into this a little bit more. Okay, so seepage from a canal is always lost forever. Is it true or false? This is false, right? Okay, so and this is the thing. So if you're looking at the efficiency of your canal, right, then seepage is absolutely a loss, right? And it's going to make your efficiency lower, right, for your canal. But where does that seepage go? That's the question in water accounting. So we're not so much interested in efficiency now. We're thinking, where does my water go? Because we know that mass is conserved. It doesn't just disappear, it goes somewhere, right? So the seepage, if it goes to salty groundwater, is that a loss or not? If it goes to salty groundwater. In water accounting, what would we call that? We would call that, that's an example of an outflow or a depletion? Depletion, right? Because it's a flow to a, what do we call it? A sink, right? Okay, so in that case, yeah, it's lost, right? And unless we pump that water and we filter it, maybe with reverse osmosis, and spend a lot of energy and money to clean it, it's kind of lost, right, at that point? But if the groundwater is a freshwater, healthy aquifer system, and that canal seepage goes down into the fresh groundwater resource, is that lost forever, that water? No, because maybe it comes out into the river, or maybe to the next canal, or maybe the next farmer can pump it and use it, right? Now there's reasons to make efficiencies high, like to stop the seepage. There might be reasons to do that, maybe from a water quality perspective, maybe from a power perspective. Maybe you don't want the next farmer to have to pump it. Maybe if you line your canal, you can get the water there in the canal instead of having pumped. So there's reasons, but the water is not lost forever. That's what water accounting shows. This is obviously a tough one here. Okay, so very even distribution.
Yes.
Except for this one. Okay, that's good. Okay, in the most, Kuzma went over this at the very end, and I'm not sure what definition he had, so I wanted to introduce this. So the idea of a productivity is kind of like what you get out versus what you put in. That's the generic definition of productivity. What you get out over what you put in, okay? And it's a ratio, right? And so in terms of when we think about water productivity, and let's think about crops specifically, so like rice field, right? And what do we get out of a rice field? Yeah, and what do we call that? Yeah. Yeah, it's a yield, right? Okay. And since we're talking about water productivity, what do we put into the field? Water, right? Okay. But here's the difference, and this is why I wanted to ask this question, is what do I have here in the denominator? You guys know numerator, denominator? Like the top of a fraction is the numerator, and then the bottom is the denominator, right? So I'm going to use those words, but it just means top and bottom, okay? So in the denominator here, what is this? Okay. So there's different people think maybe different things about this. Some people think, we should put the amount of water that we put on the field down there. And some people think, no, it should be just the amount of water that the crop uses. Okay? But I think that having this number, ET, is the best number, because the rest of the water is not lost. It's not depleted, it's an outflow, right? Okay, so other people voted for this one. This is the one that we just talked about, right? This is be like what you divert from the river way back over here. But some of that water seeps out of the canal, and okay, so typically this is not how we look at it. We look at it like this. For that field, how much water was actually evapotranspirated? Okay? So that's a little bit new. We'll spend a lot of time talking about that in later trainings. So what I'm wondering here is this a concept that you guys think would be helpful in VMR? Okay. So it sounds like overall this is maybe something that could be useful as a tool for you, right? And I'm really interested in having that discussion with whoever's interested in it. So maybe we talk about this more during the breaks or something. But if there's people that are interested in this, I can help facilitate that in terms of the technology, because we have something kind of developed that's free for you guys to use. So let's start maybe thinking about how to use it. Okay. Okay, remote sensing observes different portions of the. Wow, excellent, good. I wish we could directly observe the space-time continuum, but I haven't figured that one out yet. So let's one more question about remote sensing here. So what type of data can we get from remote sensing? Excellent, yeah. And this is true. We can get precipitation data, but we can also get evapotranspiration with the surface energy balance. We can also get snow cover. I have one question I didn't add I want to ask real quick. The difference between active and passive remote sensing. You guys remember what the difference is in the example that we used? So what is the difference? Someone just share?
Active, they capture the cascade and
Yes, yes. Okay, and passive?
that's it. We do not rely on the signal transmitted from the sensor.
Yes.
It's record the energy reflected from the surface or emitted from the surface.
Yes, excellent. Okay. So remember, what did we use as an example of that? We never forget our example. The plot, right? Okay, okay, good. So these pictures help us remember things like that. And how do we remember net inflow and gross inflow? Remember the storage, right? Okay. We never forget. Okay. Just curious to see if people think this is helpful or not. I mean, practically, I don't want to hear like there's no right answer, but I'm wondering practically, can people use this tool? Okay. Okay, so in terms of designing the next training, would it be worth spending time on this material more, on GIS and remote sensing? You guys think that would be a helpful material or no? I mean, this seems like yes, but okay. Last question. Everybody take votes. Right. There's one person that can leave.
Yeah, one does not, one is not. Maybe we have to go back to the old.
Okay, good. Well, so am I. I am also ready. I vote strongly agree. And I have one last question. Did anybody actually read all of this? I'm wondering. I didn't. So I've read it before, or a few times. But it's just, you don't have to get it out. I'm just curious. Did people find this? I think the first paper we found helpful, right? The first paper from Molden, it was helpful. Was this one helpful at all? It's okay, you don't have to find it. I'm just asking a question. Was this helpful to read or not? I really want to know. I want to know if I should use it for other.
Thế là phát lộ xin bia là ai? Bia người là bia họ tham gia việc lại, bia họ tham gia phát đầu đó. Thì bia đồ là phát là bia đồ là người ta đi ra được. Còn sai đó có bỏ nếu ta ông ta rồi đi ra đồ tiền mua về tông đường sản phẩm, ta ra phát hiện được nhà du lịch thì mà bia uống sủi là đi nấu thì những cái này sắp có lòng ngon nó qua đến đâyအချက်အလက်ပေးတာနဲ့ဆိုင်ဟိုကျောင်းသားတွေတင်ယူရတဲ့လူတွေဘယ်လိုရနိုင်လဲနော်အားဖြင့်သိရှိတယ်ဒီကဟုတ်အကြောင်းအရာဝေးတာဒီ English ကဟုတ်တယ်အင်္ဂလိပ်ရေးတာနည်းနည်းလေးပါဖြစ်တယ်လားရှင်းသုံးဖြစ်လို့နော်I have a look. We shall hold the name of a job. I don't know if you know how to do it. Send us a cool, the Semena of the I don't know. A young yard they are taking it, no?
So what was the consensus?
Well, as we label, one of the things, the reading was a bit difficult.
Yeah.
Some of the things due to the technical terms and being out of the domain. But some of the things English.
Yeah, the English, well, because it's old. You know, it's almost 80 years old, right? But I wonder if those 3 points, you know, I didn't ask. I should have asked the question, but I have maybe 1 or 2 more questions. We'll do this old-fashioned way without the computer. When you pump a well, right? When you pump a well, water comes from somewhere, right? There's no new water being made. So what are the three sources of water to a well? Please don't look at your paper. We're gonna try to do this from memory here. So initially, right, early it comes from. Okay, well let's split up. Very good, very good. So when you start pumping initially, where does the water come from? It comes from.
ဒီရင်းဖက်ကလေးတူးလုံးတော့ဘယ်ကနေရလဲ
Yeah.
ဒီနဲ့
And then as that cone, what is this called again? As the cone of depression grows, right? At some point maybe it hits the recharge. And then when it takes the recharge, what do we call that?
ဒီချာကိုဆွဲယူတာ
Juice recharge, yeah. And then maybe it comes down and it hits the river where the water was discharging and it starts to take reduced discharge. Okay, very good. So that's really, really fundamental to groundwater management. If we have that in our minds, we always are thinking, where's the water coming from? Is it coming from storage? Is it maybe gonna take the discharge from a spring? Maybe if I pump, it's going to dry the spring up. Maybe if I pump, it will dry the river up. Maybe if I pump, it'll pull more water in as recharge, right? These are the questions we should always be thinking. It comes from somewhere. When I pump that water, it's going to come from somewhere, okay? Many people in the U.S., in fact, our laws in the U.S. oftentimes treat groundwater as if it's like a separate bank that just is like this infinite supply. We can pump as long as we can, it'll always be there. It's not true.
It is everywhere in the world, not only in India.
Yes, thank you. I pick on my own country because we can pick on our own country. But I think everywhere in the world this is. So I agree. It's like this mysterious, infinite resource. And it's not. Okay, so here we are. This is going to be the schedule for today, if you look at it, is we have 4 sessions again. And most of the session is you guys doing work now. Because the first 2 days we spent a lot of time building the foundation, right? And now it's your time to apply the theory, okay? And when you apply it, we realize, okay, we need to work on this, we need to work on that, okay? But this is where you take your pencil and your paper and we apply these things, okay?
Jeff,
So the first-
before we move,
Yeah.
I would like to introduce my colleague here. He is here for a few days.
Oh, very good, okay.
Uh,
I'm sorry.
Actually, he was here for a mission. So he thought, why not to attend one day this workshop and also meet some colleagues. We work together in Bangkok, and he more looks at disaster risk management or climate change or this sort of issues, and water is the integral element. So he thought, why not to join this one, also get introduced with some of the colleagues who are working in this field, and also to be here. So would you just shortly introduce?
Good morning. My name is Hideki Kanamaru, Climate Change and Disaster Risk Reduction Officer based in regional office for PPO in Bangkok. So very glad to meet you. Thank you for the opportunity to sitting here. I did the worst in the Kaput test because I was
Okay, so maybe you were the one person. It's good. Everybody's safe now. We have a scapegoat or someone to blame.
Yes. In the break on the lunch, I'll be happy to talk with you to learn about what you are doing in the water management. Particularly, I'm interested in learning about your activities related to drought, if any, because we are starting a new regional program on drought management together with Cambodia and Laos. Thank you.
Yeah, very good. Thank you for joining us. Yeah. So just for one day, just today?
Just today in this workshop.
He's here until Friday.
Tomorrow, Friday, I have many appointments.
Yeah.
Some of the appointments with your colleagues in the ministry.
Excellent. All right, great. Great. Yeah, Puspa, do you have anything else? Because Puspa has to leave today, so this is.
Yeah, but I'm here until 5 o'clock.
Okay.
My flight is at 5. So
Okay.
Sorry, 7:30. So
Okay. Okay. So if we look through the schedule now for today, the first two sessions are all about precipitation. Okay. So now what we're doing is we talked about the framework for water accounting. We talked about fluxes and changes in storage. And now it gets down to specifically, let's choose the important fluxes and the important changes in storage and like kind of zoom in now and do some practical work with them, right? So when we think about our Palais subbasin again, what is our primary, actually our only way that water comes into our domain? There's only one way water comes into our domain. And it's from precipitation. Okay, so that's why we're going to talk about it first, because it all starts with precipitation. If we get precipitation wrong, then everything else is wrong, right? So we can't get precipitation wrong. We have to figure out what actually is that amount. That's what we have to work with, right? So that's what we're going to do for the first two sessions. And then we're going to keep evapotranspiration and groundwater tomorrow, because those are going to be kind of a little bit more challenging. We're going to move then to surface flows. So how do we measure surface flows? How do we take surface flow data and convert it to water accounting for our water accounts? Okay. So for precipitation, what I want to start with is this little exercise. So I call this think, pair, share, okay? So that's going to be kind of the rhythm for the first session, is we're going to do this think, pair, share. So what I mean by this is I want you for 10 minutes to, on your own, you can use your computers, you can use any resource, but I want you on your own to just think about how do we measure precipitation, right? Maybe you have some personal experience. Maybe you can look on the internet. Maybe you can draw some pictures. Where should we measure, right? The strengths and weaknesses of these different methods, but this is your time. For 10 minutes, you do your own research. You can read what we went over yesterday. Please don't look at the notes for today, though, because we'll go over those together. So don't look at the notes. I want you to think and find on your own, not using the resources I've given, okay? We make a deal on that? Shake? Yeah? Okay. So I want you to do that for, 10 minutes. And then, how are we doing on time here? I think I'm going to cut this down, just because somehow I always end up being behind. Can we do 5 minutes of thinking? And then 5 minutes of pairing. So I want you then to form a group. It can be your whole table or just two people or whatever. Just talk about what you found. We can measure with this. Maybe we should measure it this way. Here's some ideas, okay? So that's where we pair up. And then I'm going to choose a few groups to come up and then share what their thoughts are about this, okay? So that's the thing. Think, pair, share, okay? Is this clear? Okay? So let's start thinking, and I'll tell you when we move to the pairing, okay? Okay, so you're going to use the internet, just don't use what we gave you today. This one here. Yeah. So don't look at these notes from today. Yeah. Okay? I just want to add one more thing to think about. So think about how to measure precipitation, but also like how precipitation works. Like why does it rain more in some places and less in some places, and that sort of thing. Okay, so just one more. Just how does the process of precipitation work? Okay, I think it's time to transition to pairing up. So choose your neighbor or your whole table group or however you want to do it, and just discuss what you learned. Okay? Pair up.
ကိုရှာဝေတွေ့ရှိသူကနာပြုတ်ပြီးတာလေးကိုနှစ်ယောက်ပေါင်းမလားသပွဲတစ်ခုလုံးပဲပေါင်းလုပ်မလားရတယ်ဒါတော့ကျဲတယ်ဟုတ်ရအောင်ထီလိုပြောလိုက်တယ်
ချိန်ကလည်းကျွန်တော်တို့ပုစုလိုက်ဆွေးနွေးရမယ်ချိန်ကဆွေးနွေးပြီးတော့မှကျွန်တော်တို့နောက်ဆက်တဲ့တက်တော့နောက်ဆိုရင်ကျွန်တော်တို့ရှိမှထွက်ပြီးတော့ပြောအောင် Okay, so what you want is we want like just like a 1 minute, just very short little presentation from a few groups of what they learned, okay? And I'll just pick groups, okay? So we'll start maybe 3 or 4 minutes, okay? It doesn't have to be perfect. It's okay. Okay. Well, I can tell you guys are just getting started. So now I have to stop. We will have more time for this moving forward. So we're going to do this 3 more times for each of the primary kind of fluxes and changes in storage. This one is the shortest because we had to review this morning of the previous material. Okay? You guys are so enthusiastic. Okay, I can call on people. I will if I have to, but it would be great if anybody wanted to volunteer. Would anybody like to go first? Yeah? Thank you. Oh, great. Okay. And we're going to have a gender balance. So the next group will be a group of ladies. Okay. So you want to go next? Yeah. Okay. So we're going to try. I know we don't have much time, but we're going to try a short summary. Okay. So. Nothing will get you to learn something like if you have to teach it. When you have to teach something, you have to learn something. So that's the point of this. Okay, so maybe just very good. Just share some examples. So yeah, please share.
这里面 measure the ideal I hope we can measure the rainfall data on the ground base and satellite base. For the ground base, we can directly collect the data from weather station like the rain base. There are maybe the automatic and manual. And also we have a ground bay radar equipment radar station, so we can get the data from this station also. And also we can get the satellite base. But we cannot use the directly from the satellite measure. We need to calibrate with the ground station data.
Okay, very good. Would you like to come? Thank you, very good. I think your English is better than mine.
We have with the call with Louis, I didn't have it. I didn't. Yeah. So I think it must be. I'll go look. In the black room.
Okay. As our group, we have there is three measurements for the precipitation. One is rain gauge and satellites, and also S4W. So for the rain gauge, we have strength and weakness. For the strength, there is a terminal recorder because we cannot it cannot destroy easily, and we can get through measurement. But for as a weakness, it is expensive for the local people, and also it is time wasting because we need to add the data to computer from the paper sheet. So it's some kind of time wasting. And also another is no backup data. When we get the data, even after we have added it, there is no backup data. It is wrong or right. So for the satellite remote sensing, we can get a large area coverage for continuous data, and it is easy to collect. But for picture. So it is wrong or right, we can back up the data and we can fix the data. But for the witness, it can be wrong in reading. It depends on the eye error or something like that. Thank you.
Yeah. Oh, very good. Thank you. So that was very nice. We had the evaluation of these different techniques. Very good. Very good. We can have one more group go. Would anybody, yeah, would like to go? Okay. I don't even have to call on people. They just volunteer. I'm sorry, the groups that don't get a chance to go, we'll make sure that other groups get to share for the next activity, okay? Oh, here, you want black or blue? Okay, which one? Good, it is a water. You guys can also share in Myanmar. There's no reason you have to do it. You're not teaching me. What I understood from that was that the wind can have a significant effect on the air rain cases. Yeah, it's true. It's very true. It can be, for snow, it can be up to 100% air because it's so light. The wind just makes it avoid the case. Very good. Yeah. Okay. So this is great. Remember yesterday I asked if any of you had ever measured the flow in a stream before? I think you said nobody had ever, right? And And I'm going to ask you now, has anybody ever measured precipitation in this group? Has anybody ever taken a measurement of rain or snow or anything?
ဘိုးကြီးကိုယ်တိုင်ထင်ဘူးလားရှိပါဦးကျော်
Yes, you have. Yes?
Okay.
Yes. Thank you. Okay, so in the school that I did my bachelor's in, we have this saying. We have like a important concept. It says learn by doing. Yeah? Learn by doing. The best way you will ever learn something is by doing it. If you want to know and understand precipitation, you start to measure it. I started measuring precipitation when I was 10. I'm a really, if you know the word nerd, you know the word nerd? Is there a word in New York for that? So, but my dad taught me to measure things when I was very young, right? But if you want to know something about precipitation, you can build your own rain gauge. I have a video I can share with you on YouTube. You can just Google it, it doesn't matter. You can buy one for pretty cheap, but just put one out at your house, and after when the monsoon comes, it's really interesting. Yesterday, how much did it rain? 100 millimeters, 50 millimeters? It's pretty interesting. I think you'll like it. I think. And if you want, you can then record the data with the phone so that we can all use it to share, right? So learn by doing, please. Okay, so we start to do some of these things. So we have an option now. We're supposed to have a tea break in like 5 minutes. But we have maybe about 20 to 25 minutes of theory of precipitation from our lecture notes. So we're going to talk about the mechanisms of precipitation and then show some pictures of what you guys have already learned yourself, right? Should we do that now and then take the break? Maybe a short break, or should we take a short break now and then come back and do it? You guys tell me what you would. Either way, we're going to have a bit of a shorter break. It's okay, 15 minutes. But we want to do that break now or after the presentation of materials?
အခုပေါ်ပြီးတော့မလားတဲ့ဟိုပုံလေးတွေရင်ကြည့်မလားပြီးတော့ပြန်လာမှပဲကြည့်မလား
After presentation.
Now or after? Sorry. After? Can we take a little break then? No. This is the problem with democracy. We always disagree. Presentation now. So presentation now. Who wants that? Yeah? Okay. I'm sorry. There's always winners and losers in democracy. It seems like maybe you guys want to do it now or later. Okay. You make, what do you think?
Someone else saying either.
If you don't vote, you don't get to say that. So okay. Good. I just don't want to do too much, but we haven't really covered much new material. So this is the new material for today in terms of precipitation. Why is it not opening? Okay. All right. For my I've been losing stuff lately. I lost my water bottle. No, I can't find it. Well, where did it go? Okay, whatever. I'll just do it. Okay. So found it. Put it back in the case. Okay, precipitation. This is the outline of what we're going to cover. We're going to talk about what are the processes that cause precipitation? Why does it rain? We need to know something about that for water testing. And this will help us understand how we measure it, why we measure it, how many places we should measure it in, right? And then, okay, so based on the theory of how it actually works, then how do we measure it? And you guys have done that research already now. And then this idea here of uncertainty. Have we heard of this word, uncertainty? We're gonna talk about that because uncertainty is fundamental to water accounting. We always should have uncertainty on our minds. Okay, so we'll talk about that for a second. Okay, so first of all, remember that nice picture we had of the water cycle, right? Very simple: evaporation, condensation, precipitation, runoff. Again, right? This is that same picture, but now it's more kind of spatially explicit. What I mean by that is it's kind of broken out by land use and by whether it's the ocean or the land, right? And then now we actually have numbers on here. These are estimates. This is interesting. In terms of the fluxes, they're all shown in arrows, and the size of the arrow has to do with the magnitude of that flux. And it's in 1,000 cubic kilometers per year. Okay? So what's interesting here is where does most of the precipitation on the Earth happen? And this may be intuitive. So if we look, so here's precipitation here, and here's precipitation here. Right? So where is most of the precipitation happening on the Earth? It's mostly over the ocean. Does that make sense? That makes sense because the ocean covers most of the Earth, right? I think it's like 2/3 or something. Okay? And then in terms of precipitation, the majority falls as rain, right? But then maybe about 10% as snow, about 90% as rain, right? But this is, to me, this is really interesting. You have to kind of think about, can I draw a domain on here? Okay, I'm going to draw a domain right here. Like this. This right here. Okay, so there's my domain. If I look at the domain, where is precipitation coming from primarily? This is really, really surprising. So here's my domain. I have inflows and outflows. Change in storage is 0. Okay? Where does most of the precipitation come from? If this is my domain right here. First of all, what are the inflows? There's 2 inflows to that domain. What are they? There's this one, right? And that's water vapor coming from the ocean onto the land, right? And that's 46,000 cubic kilometers, right? Where does the rest of the precipitation come from? See this arrow right here? Interesting, right? Isn't that interesting? So most of our rain actually comes from water being evapotranspired and then raining again somewhere else, right? That's interesting. So it's called recycling, moisture recycling. So there's a kind of a net inflow from the oceans, but then there's also this recycling component. Okay? So this is important. So that's what we're talking about. This is precipitation. This is its share of the global water cycle. And if you add up all the other things down here, it would add up to 111. Because it has to balance, right? Conservation of balance. Okay. So here's an animation of the amount of rain per month in millimeters for the whole world. Okay? So can we first, let's find my home over here. So here we are in June, July, it's dry, very dry. September, October, the winter starts, now it's raining. We have the jet stream comes, it rains until about April, and then it's dry for about 4 or 5 months. That's how climate works in California. Very hot, dry summers, almost never rains, very cool, wet winters. Okay? So can we find Myanmar now? Okay, here we are. Okay? So it's very dry. January, March, April, starting to rain. Okay, intense rain. Look how dark the blue is, very intense. And then the monsoon recedes in October, September, November. Sorry, October, November, December. Okay? So this is pretty interesting animation, right? You guys have this on the slide. You can look at it closer. The scale here is from 0 to 200. I actually can't read that. Yeah, it's from 0 to 200 millimeters per month. So you have over 200 millimeters per month during the monsoon months in all of South Asia and Southeast Asia. Okay? So that's kind of the context here. If you aggregate that over the whole year, this is the picture you get for the global distribution of precipitation, right? So the wettest places on Earth are here in Southeast Asia, and here in the mid-belt, the tropical belt of Africa, and then in South America here in Central America. So those are the wettest places on Earth. What do we call this band here? Yeah, the equator is the thing that goes right through the middle, and if you go north and south of the equator by about 20 degrees latitude, it's called the tropics. Okay? Yeah, so it's the tropical belt there. That's where most of the rain happens. I lived over here now in the Netherlands, so it gets about 750 millimeters of rain, and then here Myanmar's in the 2,000 to 2,500 range millimeters per year. Okay? So where is it driest on Earth? Look at these colors. It's the brownish color. Yeah, what do we call this right here? Sahara Desert, right? Right? So the Sahara Desert, and then you have the Middle East here, the Arabian Peninsula, right? These are the two driest places on Earth, okay? And also, interesting, Mongolia is quite dry. Some of the ex-Soviet bloc countries there. Okay. Yeah, and then also, this is South Africa. I forget the name of this country here, but I'm surprised by how dry that is. Is it? I think Ethiopia is up here. Yeah. We'll have to look it up. Sierra Leone's up here. Anyway, we'll look it up. Okay. Precipitation is any product of the condensation of atmospheric water vapor that falls quickly out of a cloud. Okay, that's the technical definition. You have it in your notes. Don't worry about memorizing it. It's just when water goes from the air onto the ground, right? And the main forms are drizzle, rain, sleet, snow. I honestly don't even know what that is. We'll look it up. It's some mix of, it's like a hail, snow, thing like this.
Somewhere between snow and hail.
Exactly, and then hail here. Okay, so the key concepts here it has to do with water vapor. So we're going to talk about this water vapor, and then saturation. This idea of saturation. Okay, we're gonna kind of walk through how that works. Water vapor, saturation. Okay, fog and mist are really not considered precipitation, but they're actually just the water just floating around. It's in suspension, we call it, in the air. Okay. Now, here's the key principle with rain and precipitation. This idea of saturation, it has to occur for it to rain. It has to be saturated before it rains. And there's really two ways that can happen. So you can either cool air, okay, or you can add more water vapor to it. And in both ways, you can saturate the air. Okay? That's how saturation works. I'm going to make some pictures now of this process. Okay? So remember, though, saturation is what causes precipitation. And the way you can saturate air is either by cooling it or by adding water vapor. Okay? Those are the fundamental processes we need to understand. Okay? I have this in here, and I think I'm going to skip it because it's really not worth going through. Let's make some pictures of what this looks like. Yeah. I think we can also make pictures of what you have in your notes so you can read it later. Okay. Now, so again, what needs to happen for precipitation to occur? The air must become saturated, right? And how does air get saturated? There's two mechanisms. Air can be saturated by either cooling it down or adding moisture to it, right? So those are the things. Okay. So now let's look at this. So in terms of mechanisms of precipitation, these are the three mechanisms. stratiform, convective, and orographic. These are a whole bunch of new words. It's good to learn these because it's very important when we come to understanding precipitation, okay? Stratiform, convective, orographic. We're going to look at some pictures now of this, okay? Okay. So this is a really nice picture from the internet. I have the link down here. What I want you to imagine is that there's two masses of air, right? There's this one here. This is cold air, okay? And then this one up here is warm air, okay? So warm air and cool air. Now, first of all, which of these is more dense? You know, dense, like if you put warm air and cool air together, which one would go to the top and which one would go to the bottom? Yeah, warm air, hot air rises, right? Cool air sinks. Yeah, we know that, okay? Right, so you see this picture? The cool air is like down on the ground, right? And the warm air is also on the ground, but what happens when the two collide? See, the cool air is moving, and then the warm air is just kind of sitting here. So what happens here as that cool air comes? You know what it does? It pushes that warm air up. You see that? It's like a wedge. You've seen a tractor or like a bulldozer pushing the earth? You know, it comes along like this and it pushes the dirt. As it pushes it, the dirt comes up, right? So that's what's happening. This is like a big bulldozer, right? It's pushing the air, and then that warm air is forced to go up, right? Now, when warm air goes up, has anybody ever been to the mountains? Have you ever been up to the snow, maybe in the Aoani or even in the higher mountains here? Does it get cooler up there or warmer? No. It's cooler in the mountains, isn't it? Yeah. So what happens to this air as it rises? It cools down, doesn't it? Yeah. And remember the thing about saturation? One of the ways to make air saturated is by cooling it, right? I wish I could do an experiment with you guys, but you just have to trust me on this. Cool air cannot hold as much moisture as warm air. Warm air can hold lots of moisture. You guys know this actually. Okay. Have you ever been outside on a really warm day? Does anybody wear glasses? I think you have glasses, right? Really warm day. And you're outside and you're walking around, and then you come into a cool building. What happens to your glasses? Yeah, you have that condensation, right? And that happened because of this. Because all of a sudden it cooled off, and that moisture, it has to condense, it has to saturate, right? Okay, so that's what's happening here. And as it cools off, it starts to condense, and then the moisture has to be dropped, okay? So that warm air has some moisture, and it rises, and it precipitates. This is called stratiform. It's a cold front, okay? So this is the first type. There's also warm fronts. So this is a cold front. The cold is coming. Okay, warm front is now, consider now that the warm air is the thing that's moving, and the cold air is kind of just sitting still now. So in this case, the same process occurs. The warm air slowly rises, and then slowly rains. But this is a little bit more of a calm event, because here, see, it's just like a very gradual kind of rain. And it just kind of gradually rains. Where this one here, it can be very drastic. You see this? This is a lightning strike, because this can happen like very dramatically, because that cold air just pushes it up, like that. But this one here, it's kind of gradual, very gentle. Okay. So that's stratiform. So do we have a picture now of what that is? Yeah. This is one way that it rains. Okay. Another way that it rains, this is in Malaysia here. Just an example of that. Okay. Have you ever had hail? Do you know what hail? The big ice stones. Do you have that in Myanmar? Yeah. Have you ever wondered how that is formed? How is that? How is hail come from the sky? How do the clouds carry that hail? It's heavy, right? Those are interesting things. This is how convective storms work. You get heating on the ground, right? The sun, it's very hot. It heats the air, and that air starts to rise, right? When the air rises, it cools down. Okay? When it cools down, the water condenses, but then you get more heat, lots of energy coming and rising. Okay? And then you start to get these circulations in there. And the circulations are so strong that they can carry the ice up the cloud, and then when it gets heavy enough, it goes back down. And then it carries the ice up again, and it makes more ice on it that time. And then it goes back down. And then it goes up again, more ice. And you can get hailstones this big if you have a really strong storm like this. So this is convective. It's these big, tall clouds. Have you ever seen these clouds?
Bố trình đảo đấy, trình đảo you do it, okay? I think I will do a little explanation.
Please, yes.
I think they all get lost.
Yeah.
ဆိုတော့ဒီဘုံတင်တော်ကြီးတဖြည်းဖြည်းနဲ့ထုံးလာတဲ့အခါမှာဒီဆောင်းပိုင်းမှာတော့အောက်ခြေကတွေကနွေးလေးကြောင့်မလို့အပေါ်ကိုဒီပြီးတက်ရင်းနဲ့အေးတဲ့အပိုင်းလေးကိုရောက်လာတဲ့အချိန်မှာကြာတယ်အထဲမှာဒီနည်းနည်းလေးစပြီးတော့ခဲတယ်ဒါပေမဲ့အဲ့ဒီအထဲမှာလေကပတ်နေတယ်ပတ်တဲ့ဥစ္စာမှာအောက်ကိုတိုက်ချတဲ့နေရအပေါ်ကိုတက်တဲ့နေရအမှဒီ down drop နဲ့ up drop အဲ့ဒါကိုအပေါ်ကိုထောင်တိုက်နေလေအောက်ကိုပြန်ချတယ်အဲ့ဒီကတိမ်တောင်ကြီးကကြီးတော့တယ်အထဲမှာကိုပတ်နေတော့အောက်ကိုတိုက်ချတဲ့လေနဲ့ရေခဲတုံးလေးတွေကကြာဒါပေမဲ့အောက်ရောက်တာကနည်းနည်းလေးပြန်ပေါ့သွားတဲ့အချိန်နဲ့အပေါ်ကိုထောင်တိုက်တဲ့လေနဲ့လည်းတစ်ခေါက်ပြန်ပြီးတော့တိုက်ပြီးတော့အပေါ်ကိုပြန်ပါအောင်တယ်အဲ့တော့ပိုင်နဲ့အပေါ်သားရောက်တဲ့အေးတဲ့နေရာကြီးနည်းနည်းအေးရတဲ့နေရာရောက်တဲ့အခါမှာရေခဲတုံးကကြီးလာဒါပေမဲ့ကြီးလာမယ်ဘယ်လောက်ပဲကြီးတစ်ချိန်မှာဒီလေကမပင့်နိုင်တော့တဲ့အချိန်ကြတယ်တော့အဲ့ရေခဲတုံးကမပြတ်ဘူးကြာဘာနည်းနည်းကြာပါလေဘိုးသီးတွေနဲ့ကြာခေါင်းပိုင်ဝဲတယ်သိတော့သိတယ်နော်လူအောင်သိတယ်ကိုဟာတွေကတတိဆန်နေသိတော့ကြာပါတော့နော်အဲ့တော့ကိုယ်တိုင်ရောဒီဘိုးသီးတွေ့တာကိုပြင်ထပ်ပြီးတော့ထပ်ပြီးလိုက်ကြောက်တော့ပြောလို့ကျွန်တော်နော် Yeah, I think they got the idea.
Okay, excellent.
It's so common.
Okay, great. Okay, so this is the second form. So the first was called stratiform, right? And that's where two different temperature air masses come together. Maybe the cold one's moving, maybe the warm one's moving, okay? Then there's convective. These are big, tall clouds called cumulonimbus with the hail, the lightning, very intense rainfall. Now, in terms of our interest, stratiform rain is more uniform. Like maybe the rain in the Calais subbasins, maybe if there was a stratiform storm, maybe it's similar everywhere. Convective, it can rain 100 millimeters here, and 1 kilometer there it could be dry. Very different, called heterogeneous, another big word. Very different, don't worry about that, just different. Okay? So that's an important point. These are some sort of convective processes happening here in Nepal. These are some of these big, deep clouds here. Not the biggest, but just to kind of ask you. Okay? And then this one is very important. This is the last one for Myanmar. This is called orographic. Okay? If we imagine, say, Rakhine State, yeah, over here on the west of Myanmar, the monsoon comes which way? Does the monsoon come from the Bay of Bengal? And it moves like this, kind of to the north east, doesn't it? Yeah. The monsoon's coming like this.
It comes from the southwest.
Yeah, it comes from the southwest and moves to the northeast. Yeah. Okay. So when the monsoon comes and hits the Rakhine State, these hills, what are these called? It's the Kachin. No, I'm thinking through them. It's the Kachin, and then the Chin, and then the Chin. Right? Okay, so the Chin is the right one, right? So when it hits the Chin Mountains, that air, or hills, that air has to cool down to cross over, right? And as it cools down, the water condenses, it rains, right? But then, it goes over the peak, and then what happens? it warms back up and it's a rain shadow. Have you guys seen this before? Like, who's from the mountains? Does anybody live in the mountains? You've never measured rain and you don't.
No, she has made.
Yeah, who's?
That lady, and
Yeah.
I think she lives in the southern part. Chama. တောင်ဘက်မှာအဲ့ဒီတင်းသားကြီးကတဝဲမှာဟိုမိုးရွာတာသူပြောပြလို့မရဘူးလား။အဲတူလား
အဲ့ဒီဟိုဆောက်ဝတ်မော်ဆိုစီနေမှာဆိုရင်ဘယ်လိုပေါ်မှာလဲတရားလက်မ200
။နံပါတ်200
ဇူလိုင်
ဟုတ်
ဩဂတ်
ဟုတ်အဲ့ဒါဘယ်လိုမိုးများမသုံးပြလဲပါတောင်တက်မိုးလားအိမ်ပြိုမိုးလားပြန်ကြမိုးလား
အဲ့တော့သူရိမဲ
ညာ
ဒီပင်လယ်ပဲနေလာတယ်
ဒီလေရဲလာတော့ဥစ္စာမိုးတော်တယ်တက်နေရော
ဟုတ်ကဲ့
တောင်လန်းနေတော့မရှိ
မရှိဘူး
Okay, so this one lady like she lives in the southern part where the rain is quite more heavy.
Yes.
She says that most of it is like carried over by the monsoon.
Yes.
Yeah, they don't really have that high mountains, but
Okay.
really hills.
Okay, yeah, okay. Well, in the places that do have hills, like the Qing ones over here, what is it, is that right?
Well, the shingles are a little up north, and we call this the Rakai mountain range.
Oh, okay, good, that's easy, that's easy. The Rukai Mountains, okay. So with the Rukai Mountains, this is called the windward side, the side that's close to the wind would have a lot more precipitation than what we call the leeward side, the back side, right? Okay? So this is where the rain happens, this is the rain shadow, okay? And I'm going to show you some pictures of this, okay? So this is the windward side of the Annapurna Range in Nepal, okay? It is very wet. It gets 4,000 millimeters of rain. It is very, very, very wet. And I walked up this canyon here about 25 kilometers, and you know what it looked like? It looked like this. It's very, very, very arid. I also went a lot higher, so it changed the scenery, but most of this is because it's so dry. It's also cold, but it's very, very dry. Just in 20 kilometers. It's because all of the rain, right, happened as I was walking in the canyon. And then once you get past the mountains, it's dry, right? It's very drastic. So this happens, I think, in Myanmar also. Okay. I think that we should take a break. I think we all know this about measurement. You look through this, I'm going to go very quickly through the pictures. We talked about manual gauges. These are some of the things that are important, the diameter, etc. We talked about this. This is the one thing I'll spend a little bit of time on, and then we'll take a break. These gauges here, like this one for instance, how often do you read the rainfall from this gauge?
นี่โอ้โหนะครับ
3 hours
Okay, so in Myanmar, if you have manual gauges, do they read it every 3 hours?
3 hours
Even through the night or just during the day?
ညအောင်
ညတဲ့တော့
ည
ညတဲ့တော့
ညတဲ့ကောင်ရှိတယ်သူတနေ့လုံးတော့မနှချိန်ဘူး24နိုင်ဘူး
6
6ကြည့်
03 or 003 06
အားလုံးရှိတယ်လား3နိုင်တစ်ခါတော့3နိုင်တစ်ခါဒါပေမဲ့ညဘက်မှာတော့ဒါပြင်2ချိန်ပဲနေပါဘူးเนาะ
မနေ့9နာရီ
ဟုတ်
ပြီးတော့12နာရီ
9စနေ3
ညနေ3နာရီပြီးတော့ည6နာရီ
6
midnight
အော်midnight ပြီးသွားရင်
now all zero မနေ့6နာရီ
And that's how okay. So they make 6 readings per day here. This is the touch what is here.
Yeah.
And then you start with let's say 6 in the morning,
Yeah.
then 9, then at noon,
Yeah.
then 3 in the afternoon,
Yeah.
and 6 in the evening.
Yeah.
Then you don't do any until midnight.
Yeah.
So that means like essentially at night.
It's 6 hours.
Yes.
So it's every day. 6, midnight, 6, and then every 3 hours.
Yeah.
Okay. And that's like where the government measures rain. That's the protocol. Is that correct? Am I understanding right?
ဒါကဟိုပါအစိုးရတိုင်းနဲ့ထားတာနော်။တိုင်းနဲ့ဟိုပါကနေပြီးစေး
WMO ကနေပြီးတော့စံသတ်မှတ်ထားတဲ့အခြေတိုင်းတိုင်းရတယ်
Yeah. So that is the
Standard.
yeah, that's the standard.
The standard of the เพื่อน
Okay, excellent. Thank you for sharing that. It's really nice to know. Okay. So, at the vest you have measurements every 3 hours, and at night you have every 6 hours, right? Now, can you use that for, say, like a rainfall runoff model, maybe for flooding? It's like maybe that's not frequent enough. Maybe you need every like 5 minutes or something. Is there a way? You don't want the person there to read it every 5 minutes, though, right? That's a challenge. Yeah. So that's where something like this comes in. Okay, so it's a tipping bucket. You have a funnel, right, that channels all the water. This is about 100 millimeters diameter. So this is like a close-up picture. And the water comes in and it drips on this bucket. So this is looking from the top, right? There's a small reservoir here and a small one here. Okay? And the drips collect on one side because it kind of tips. It's like on a teeter-totter. So you can think of there's a bucket here and a bucket here, right? The drips go into this bucket, and then when it exactly 0.2 millimeters come into this bucket, it tips because of the weight. It spills that water out. And now the drips start filling this side up. And then it drips, and when it gets to be 0.2 millimeters, because of the weight, it tips again, and it starts to drip in the other side. You see? So every time there's 0.2 millimeters, it tips. And what we do is we put a data logger there that records the fact that the tip happened and what time it was. Okay? And then if we count how many tips happen, say in 15 minutes or in an hour, we know the intensity of the rain. Right? Because if it's tipping quickly, wow, it's raining really hard. If it's tipping slowly, it's barely raining. Okay? So this is a very, very common automatic gauge. We don't have to read this one. Just come and download the data, and then we have the intensity of the rain, okay? So do we use tipping buckets in Myanmar? Are there any tipping bucket gauge data? Do we know? Maybe from DMH, do we know?
ဒီဟိုကနေအော်တိုနဲ့သွားတဲ့ဥစ္စာတွေတိုင်းလာတယ်ဒါမှမဟုတ်လည်းပဲဟိုကနေမျက်စိနဲ့ပဲလိုက်ဖတ်ကြတာ
It's okay if you don't know, but I'm just curious.
Yeah.
It was and manual
ဟောနှစ်ခုလုံးတော့ရှိတယ်
လုံးလုံးတယ်ပေါ့
ဟုတ်တယ်ဒါပေမဲ့အခုလိုဒီလိုပြောရနေပါဒီဥစ္စာရဲ့ဥစ္စာကိုနားလည်ကြနားလည်ကြပါနော်အဲ့ဒီပုံစံမျိုးရှိတာပဲဟိုဟာလေးနဲ့လည်းလည်းပေါ့ဗျာအလဲမှာဟိုတစ်ခုခံထားပြီးတော့ဒီဘဝဒီမှာခွက်တစ်ခွက်နဲ့လေတစ်ခွက်တည်းကြာပြီးပါဟုတ်အဲ့ဒါရှိလား
အဲ့ဟိုထဲကတွေးတာတော့မြင်ဘူးလေရှင်
ဟုတ်လားဟောအပြင်မှာတိုင်းတာဥစ္စာကိုတော့ထိုင်မကြည့်ဘူးပေါ့
ဘလို့ပြင်မှာတိုင်းတာ
အပြင်မှာဆိုတာတကယ်အပြင်မှာလေ
သုံးပါ
သုံးလားအဲ့တွေ့တော့ဟုတ်ဟုတ်
ဒီမရဘူးဘယ်လိုမရဘူး
ဟုတ်တယ်အဲ့လို report တိုင်းရတယ်ဒီဥစ္စာနဲ့တိုင်းတဲ့ဥစ္စာဒီမှာဒီတိုင်းဒီဘူးလို့ so we do have some of it so they have seen it but they cannot measure the intensity of it we can only measure the amount of rain
With every 3 hours or every 6 hours, is that right?
yeah
ဒါတော့အောင်လို့ရ
yeah but so this one is that you can have data up to hour
Yeah, you can even get it. I mean, if it's raining hard, it might be tipping every minute or two,
Right.
or something like that. Yeah. So yeah, they're not so. I mean, they are expensive, but they're about $500. So it's not like the $10,000 flow meter we talked about yesterday, right? It's a lot cheaper than that. My friend from the Malay sub-basin, and from anybody who works over there, maybe from DMH also knows. Do we have any rain gauges in the Malay sub-basin? Do we have, it doesn't matter, not this data necessarily, it could be manual data. Do we have any data about rain in the Malay? Do we have? Do we know?
ရှိတယ်မိုးကလာနဲ့တောင်းပြောတာ
ဘိုးကြီးပြောလို့ရတယ်
မိုးကလာနဲ့တောင်းပြောတာ
ဘူးကကိုပြန်တော့ပါရ
ဟုတ်တယ်အဲ့ဒီမှန်တယ်ဒါပေမဲ့ဟိုမိုးကလာကတိုင်းနေတာရှိတယ်ရှိအဲ့တော့ဘယ်နေရာလောက်မှတိုင်းတာသိတယ်
ဟိုမှာသူကကျွန်တော်တို့ကကလေးပါတော့တိုင်းတယ်သူကပြောလို့ဘူးမ
ခလေးနဲ့ပူတာဟုတ်တယ်ဒီပလဲအလဲမှာတော့
အလဲကောင်းကျွန်တော်တို့ပြည့်မရှိရှိ
ဟုတ်
မရှိပဲလေဟိုဘာပေါ့လဲ
ချိန်လုံးလို့တော့သူတို့ဟောပြောပြီး
ဆယ်တော့သူဆယ်တော့ဘာလို့မ
အဲသူတို့ချိန်ထားတယ်
ဆယ်ကျောင်းကကျောင်းကတော့ဆယ်နေရာမှာထားတယ်ဆိုတော့ရုံးဆိုင်တဲ့နေရာတွေမှာလည်းထားတယ်
ဟုတ်ကဲ့ဟုတ်ကဲ့အဲ့ဒီပလဲဒေသတစ်ခုလုံးမှာဆိုအရေးအတွက်ကံမှန်းကြီးဘယ်လောက်ရှိလဲ10ခုလောက်ရှိတယ်
ဆယ်ခုလောက်မရှိတော့ဘူးဆယ်ခုဆယ်ပုံစံမျိုးလောက်
ဆိုင်ကူတော့လည်းရှိတယ်ဆိုင်ကူတော့
ဆယ်ခုလောက်ရှိတယ်တော့မရှိโอเคရှိတော့ they do have one of the sorry rate gauges but they are like that like separate government departments so like for the agriculture department they have their offices their regional offices so they have it at their office and maybe also for the meteorological department they also have like two substations one is in the north and one is in the south sorry in the west
Of the Malay?
possibly we're talking about the domain one is in the western part one is in the northern part but not exactly a dedicated one in the middle of the city
And definitely not in the mountains, that sounds like. We probably have no data in the western mountains.
no one is in the I think in the might say ကလေးမျိုးတော့မဟုတ်ဘူးလား
ကလေးနဲ့တော့
Korea down low, no? In the west is like on the maybe okay, like relatively larger towers in the
Okay. And can we get this data? Can we,
you know.
Okay, well, let's take a break, but I'm curious if we can get these data. That's what my question is if they are measuring, can we get the data? Because we would like it for 2018. Okay, so it is, oh, sorry, 10:55. I know we can't get it like today, you know, but for the next training, yeah, we would like that. As soon as we would like that. Yeah. So whether it's like the 3 hour or 6 hour data, that's fine. Daily data, the smaller time, the better. For 2008. And then maybe from 2010 to 2000. That's better. 10 is better than 1, yeah. So we take a break. Do we make when do we come back? We're behind. Let's do. Is it okay if we do 11:15? Okay. All right. That gives us 16 minutes.